All right, you guys, we have been talking about greatest common factor. And as we look at our notes from yesterday, you can look at your vocabulary and we can talk about those three words. We can talk about the word greatest, we can talk about the word common, and we can talk about the word factor. Okay? In this case, when we're talking about greatest, we're talking about the biggest number that we can find. Okay? The biggest number that we can find. But it's not just the biggest number, there's more to this. It has to be the biggest number that is the same because common means something that is the same. You and I could say we have one thing in common. We both enjoy mathematics, right? And we wouldn't be lying about that. Everybody loves math. And factor has to do with multiplication, right? I'm just going to put multiply. So when we talk about the greatest common factor, we're looking for the biggest number and it has to be the same and it has to do with multiplication. Okay, so let's get started. Let's look at one of these. Find the GCF of 12 and 24. So you can definitely take the notes that we were working on yesterday and you can add this to those notes somewhere on the side or even on the top or bottom of the backhand side. It's up to you. But if you recall from yesterday, there's two different ways that you can find GCF. You can use a list or you can use a tree. Okay, and I'm going to show you both ways. So let's talk about if we find the GCF of 12 and of 24. So we're going to make two lists, 12 and 24. Okay, so let's think of all the things we can multiply to get 12. Well, 12 times 1, that's pretty easy. That will give me 12. 6 times 2, that will give me 12. 4 times 3, that will give me 12. Let's see if I can think of anything else. 5 times, no, nothing would give me. 6 times, well, I already did that one. 7, 8. No, I think that's about it. Okay, so those are our factors for 12. Okay, let's talk about 24. Well, I have 24 times 1 will give me 24. Okay. 12 times 2 will give me 24. 8 times 3 will give me 24. 6 times 4 will give me 24. Notice I'm kind of going in order, 1, 2, 3, 4. Okay. Will give me 24. All right. 5, no, 6. We did that one. 7. 7 times 4, 20. Nope, that one gave me 24. 8, 9, 10. I think that's about it. Okay, so that looks like just about it. Okay, so when you're making a list, a good thing to know is you just have to know your multiplication really well. All right, let's look at the things that we have in common. We have a 1 in common, right? We have a 2 in common. Okay. We have a 3 in common. So let me get a different color here. 3 in common. We have a 4 in common. Okay, we have a 6 in common. Okay, we have, let's see, we have a 12 left over. Oh, we have a 12 in common here. Okay, I see a 12 right here and a 12 right here. That's about it. Okay, so it looks like my largest number that I have that's in common is the 12. Okay, so in this case, my GCF is 12. All right, let's test that on the other side to see if that's exactly what we're supposed to, or that's exactly what we have. Let me show you with the tree, because if we do them both correctly, we should get the same thing, because we're just doing the same thing with two different numbers. So I have a 12 and I have a 24. So let's break this down. Okay, let's say 6 times 4 gives me 24. I'm sorry, 6 times 2 gives me 12. Well, I can't break down 2 anymore, but I can break down 6. I can do a 3 times 2. Can't break down 3 anymore, just it's a prime number, and 2 is a prime number, so that's as far as I can go. Okay, let's try the other side. Well, I can do a 12 times 2 gives me 24. 2 is a prime number, so I can't break that down, only 2 times 1. Then I can do 6 times 2. That gives me 12. And then I can break down 6. That's 3 times 2. So I have all these prime numbers now, these numbers that I can't really break down any further unless I multiply it times 1. So now we just have to find pairs. Okay, so I have a 3 here and a 3 here. I have a 2 here and a 2 here. Okay, and then I have a 2 here and I have a 2 here. Okay, so I'm looking for all the prime numbers, the ones that I can't break down anymore. Okay, I'm not looking for any of the other ones. I'm just looking for all the prime numbers, the ones I can't break down anymore. Okay, if I could break it down, it's not a prime number. So this was a prime number, this was. So I was just looking for all the prime numbers that I could no longer break down, right? The ones that I have in common are a 3, and then another 2, and another 2. Those are the ones I have in common, okay? Because this one right here doesn't have a pair. All right, doesn't have anybody underneath the 12 I could highlight. So let's multiply. 3 times 2 is 6, and 6 times 2 is 12. So my GCF is 12 because I was able to multiply these 3 numbers right there together. Okay, excellent. So it worked out. You could use the list or the tree. Okay, so what I want you to do now is you're going to find me for 44 and 80. Let's make a list. Okay, so we're going to do 2 different ones again. We're going to do a list and we're going to do a tree. Okay, so I want you to do make a list right now for 44 and 80. And I want you to write all the numbers you can multiply to get 44 and all the numbers you can multiply to get 80. Let's see what we can come up with, okay? So you go ahead and do that. You're going to pause it. And, well, it's not really going to pause. It's going to pause on its own. Right now I want you to tell me all the factors for 44. Okay, so let's think here. We had 44 times 1 is 44, right? 22 times 2 is 44. Okay. What about 11 times 4 is 44? 7, 8, 9. Seems about it right now. Let's go down to the bottom. Okay. So what I want you to do right now is I want you to tell me all the multiples of 80. So this is going to stop so that you can tell me all the factors for 80. So tell me all the problems that you can create to get 80. Okay, so we had 80 times 1 gives you 80. 40 times 2 gives you 40. 3, nothing goes into it. 4. Okay, what about 4? 20 times 4 gives you 80. 5. Let's see. 5, we go in 1. 3. I think that would be, let me try 5 real quick. I'm going to go ahead and do this backwards. Yep, 16. 16 times 5 would give us 80. Okay. 16 times 5 would give us 80. And then, oh, of course, 10 times 8 would give us 80. That's an easy one. And I think that's probably about it. 15, 20. Oh, and here's another one, a 20. Oh, we already got 20 times 4. Okay. Okay, so let's see, what's our biggest number that we have in common? No, both of them don't have a 44. Both of them don't have a 22. Wow, the biggest one that I see that has in common here is a 4. So in this case, it's not very big, but my greatest common factor seems to be 4. Let's test that. Let's go to the other side. That looks like a 9. 4. Okay, let's test that. Let's do 2 trees, 44 and 80. All right, so for 44, I'm going to do 11 times 4. So I want you to pause the video right now, and you're going to tell me which one of these is a prime number, 11 or 4. Which one can't be broken down anymore? All right, cool. Yeah, this is a prime number right here, the 11. It can't be broken down anymore, but we can keep going with the other one. 4 is 2 times 2. And these are both prime numbers because it can't be broken down anymore. So I have 3 prime numbers there. Okay, let's go to 80. I'm going to do, oops, doing the wrong color. For 80, I'm going to do 20 times 4. Okay, both of those can be broken down, so they're not prime numbers yet. And then we have 5 times 4. Okay, so with 5 and 4, I want you to tell me which one is a prime number, 5 or 4. You're correct, 5 is a prime number. Let's keep going. Let's break this down. That's 2 times 2. So again, 2 is a prime number. All right, let's go to the other one. 2 times 2 is 4. Those are both prime numbers. So this is a prime number and this is a prime number. Okay, but now we have to find the prime numbers that match each other. Remember, they're common, greatest common factors. So I have a 2 here and I have a 2 here. I have a 2 here and I have a 2 here. That's all that matches. So I have a 2, a pair of 2s, and another pair of 2s. So 2 times 2 is still 4. My greatest common factor is still 4. Okay. Well, that makes sense because the list showed a 4. Okay, let's keep going. Greatest common factor of 36 and 54. Okay, so let's make our list, and then we'll try a tree. Okay. For 36, I want you to go ahead and show me all the greatest common all the problems that you know that could equal 36, all the multiplication problems. Okay, let's do this. 36 times 1. Okay. 18 times 2. 3. Ooh, 12 times 3. 9 times 4. Okay. 5 doesn't work. 6 times 6. 7 times nothing. No. 8. 8 times 4. 8 no, that wouldn't work. 9. We did that one. 10. 11. 12. 12 times 3. We got that one. 13. Nope, I think that's about it. Okay, let's go to 54. Okay. 54 is always a hard one, but the first one that comes to mind is 54 times 1. Okay, that's the first one I'm going to go to. And then we have 9 times 6. That gives me 54. That's an easy one. What about 27 times 2? That gives me 54. Okay. What else could give us? Let's see. No, nothing times 4 will give it to us. Oh, I got one. Um, is it 18 times 3? Let's try that really quick. That gives us 20. Yeah, that's 18 times 3 gives us 54. Okay. I think that's about it. And it might not be, but that seems about right. I can't think of anything else that will give me 54. Well, in this case, what's our greatest common factor? So I don't see a 36 in both of them. I see an 18 in both of them. I see an 18 here, and I see an 18 here. That's the largest number. I don't see a 54 or 27 in both of them. Okay, so it seems to be my largest number. My GCF for this one is 18. Okay, let's test it by doing a tree. All right, so now we're going to do a tree and see if we're correct. All right, so I'm going to do a tree for 36, and I'm going to do a tree for 54. Okay, so for 36, I'm going to say 18 times 2. Now I already know I have one prime number, which is here. Okay, so I'm just going to leave that there for now. Then I have 9 times 2. Ooh, I have another prime number right there. Okay, let's keep going. Then I have a 3 times 3. And those are both prime numbers. Don't forget, prime numbers are those ones I can't break down anymore. It's just like 2 times 1. That's all I can use to get to. Okay. All right, let's try 54. So what I want you to do now is I want you to go ahead and I'm going to put 9 times 6 here. Tell me which one of these is a prime number. And if none of them are, just mark none. All right, let's keep breaking this down. There are no prime numbers yet. Let's get one, though. 3 times 3 is 9. So I know these two are prime numbers, right? Let's keep going. 3 times 2 is 6. And I know neither one of those can be broken down anymore, so those are my prime numbers. Okay? So now, right now what I want you to do is I want you to tell me which numbers have common factors, which numbers have pairs. Okay, so find all the pairs and put them in your answer. All right, here's one pair right here. I have a 3. Okay, here's another pair right here. Another 3. Here's another pair right here, a 2. And there's no other pairs of prime numbers. Yep, those are the only pairs of prime numbers. Okay, not 9. 9 isn't a prime number, so we can't count that. Okay, so 3 times 3 is 9. And 9 times 2 is, go ahead and put that. What is the GCF? Put that in your answer. What is the GCF? You are correct. The GCF is 18. It worked out. We were correct. Nice job. All right, let's practice one more together. Let's find the GCF of 36 and 48. Okay? Well, we have all of our multiples. Remember, we're going to do a list and we're going to do a tree. We have all of our multiples from the last time. So we had 5 different problems we came up with. Go ahead and type those in for me. What are the 5 different problems that we had? Okay, 36 times 1, 18 times 2, 12 times 3, 9 times 4, 6 times 6. All of those gave us 36. So I don't really want to do all the work over again. Okay, and all of those equaled 36. Well, let's do 48. We haven't touched 48 yet. So I know it's 48 times 1 gives me 48, right? 24 times 2 gives me 48, right? Let's think of another one. What about 6 times 8? 8 times 6 gives us 48, right? 12 times 4 gives us 48. And what else? Can we think of anything else? That's about it, I think. Okay, let's find the greatest common factor in this case. So go ahead and pause the video and tell me what's the biggest number you see in common. Yeah, I agree with you guys. The biggest number I see in common is 12. Everything else, I don't see a 48 or a 24 in the other list. So I'm going to say our GCF is 12. Okay, let's see if that's correct. Let's do a tree now. Okay, remember the trees have to do with prime factorization, which means the numbers that we can't break down anymore. Okay, so we have 36 and we have 48. So we're going to do 6 times 6 here. Okay, tell me which of those is either one of a prime number. Okay, if it is, then tell me which one, this 6 or this 6. And if not, just say there are no prime numbers. Okay, in this case, there are no prime numbers. Let's keep going because I can break this down to 3 times 2. Now, 3 is a prime number because I can't break it down anymore. And 2 is a prime number because I can't break it down anymore. And in this case, I have another 3 and another 2. And I can't break those down anymore, so those are my 4 prime numbers. Then over here, I have 12 and I have 4. Okay, go ahead and tell me, is 12 a prime number or 4 a prime number? And if neither one of them is, then put none. So which one is a prime number? You're correct, neither one of them is. So we're going to break it down again, 4 and 3. Which of these is a prime number, 4, 3, or none? You are correct. Neither one of them, the 3 is a prime number. You can't break it down. But we can break down 4, 2 times 2. Okay, and we know that 2 is a prime number, so we can highlight those. Okay, over here on the other side, we still have 2 times 2, and we already know from experience that we have 2's as prime numbers. Okay, now I want you to go through and I want you to tell me how many pairs can you find? Okay, how many matching common pairs can you find? Tell me all the pairs that you can find right now. Go ahead and type those in. Okay, we can find a 3 and a 3. That's one pair. We can find another 2. That's another pair. And then I can't find another 3. Oh, but I can find another 2. That's another pair. Those are the only pairs we have. Okay, 3 times 2 is 6. So 6 times 2, go ahead and tell me what the GCF would be. You are correct, it is 12. So we have it the same thing as we did for the lists. So now you see 4 different examples and 2 different ways you can find GCF.